Okay, lesson 80 is about prime and composite numbers. So the first thing I want you to do is write down the name prime, just like that, and then write the name composite. Okay? And we're going to go through and think about what numbers are prime numbers and which one are composites. But first I want to give you the definition of what a prime number is and what a composite number is, okay? So I want you to write this down. A prime number is a number, I'm just going to put that little number sign, is a number with exactly two factors. Okay, I'm going to explain to you what that means exactly, but just write that down for now, alright? And then a composite number is a number with more than just two factors. Okay? So go on and write that down. I'll give you a little bit of time to write that, and then we'll talk about what this looks like exactly and give you some examples. Okay, so I'm going to show you this by looking at the number 5 and 6, okay? 5 I'm going to put here, and 6 I'm going to put here, okay? Now, when you're looking at a number to tell if it's prime or composite, the first thing you're going to ask yourself is, what numbers go into this? So, for example, what times what equals 5? Okay? These places where I have a line are called factors. That's why I'm talking about factors, okay? So, what times what equals 5? The only thing that equals 5 are the numbers 5 times 1. Okay, that is the only two factors that equal 5. Alright? And that's why 5 is considered to be a prime number, because it is a number with exactly two factors. And it's always the number itself and 1. Okay? We'll do a few more in just a minute, but let's go on and let me show you what a composite number is. A composite number, let's take the number 6, okay? What numbers will go into 6? What times what equals 6? Well, immediately I thought of 6 times 1, okay? And there actually is some more numbers that equal 6. Did anybody else think of anything else? 2 times 3. 2 and 3 are two other factors that go into 6, okay? So, that's why 6 is considered to be a composite number, because it is a number with more than just two factors. It actually, this one happens to have 4, okay? But what makes a number prime is if it only has two factors, but it makes it composite if there's more than just two, okay? So, with those definitions in mind, we're going to take and go from 1 to 10 and ask ourselves if it's a prime number or a composite, okay? So keep looking at those definitions as we do this, all right? So we start with number 1, and the thing about number 1 that I want you to write down is that it is neither prime nor composite, neither one, okay? So we're just going to get 1 out of the picture. We're not even going to talk about 1. 1's not even considered prime or composite, okay? So let's jump to number 2. Alright? We're going to ask ourselves, is it prime or composite? Okay, well let's ask, what numbers go into 2? What times what goes into 2? Which factors? Okay? Hopefully you thought of 2 times 1 equals 2, and those are the only two factors that will go into 2. So guess what? It is a prime number. I'm going to put a P right there for prime. Alright, let's look at the number 3. Okay? What factors go into 3? What times what? Well, hopefully you thought of 3 times 1. Okay? And that is actually the only ones that will go into 3. So guess what? It is a prime number as well. Alright, let's look at number 4. 4, what two factors go into 4? Well, automatically 4 times 1 works, but can you think of another one? Hopefully you thought of 2 times 2, okay? So 4 has more than just 2 factors. It actually has 4. So we're going to put a C here, meaning composite. Okay? So a composite number has more than just 2 factors. These ones right here, the number itself and 1, it also has more. So it's considered a composite. All right, we just did 5 and 6, so I'm going to skip past those. Okay, and let's go on and do 7. All right, 7, what numbers will go into that? What times what? 7 times 1. Again, this one's a prime number because nothing else will go into 7 except 7 and 1. All right, now I'm going to go on and erase this, and let's do 8, 9, and 10. Look at those together. Okay, number 8. Can you think of some factors that go into 8? Well, automatically you should think 8 times 1 for sure. Any others? Well, you thought of 4 times 2, and that is it. So, as you can see, it's going to be a composite. I'm going to put a C right there because it has more than just 2 factors. Let's look at 9. I thought of 9 times 1 and also 3 times 3. So again, this one's composite because it has more than just 2 factors. And 10. 10 times 1 and 2 times 5. I think that's about it. So it's considered a composite as well. Okay? Hopefully that gives you a good understanding of what a prime number is and what a composite number is. Okay? But before we're done, we're going to talk about a word called array. Okay? And what an array is an arrangement of objects that complete a column or a row. For example, I'm going to draw a array for 12. Okay, for the number 12. And so I'm going to ask myself, what times what equals 12? Okay, I thought of 4 times 3 instantly. So if I'm going to make an array of this right here, 4 times 3, this is what it would look like. I'm going to use X's for my object to make this array. Okay, you can do dots or whatever, but we're going to use X's. And so I have 4 X's how many times? 3 times. So I will have 3 rows of 4 X's. And if you counted all those X's, we would get 12, okay? So what I'm showing here is that I have 4 X's 3 times. 1, 2, 3. Just like that, okay? So this right here is an array for 12, okay? But sometimes it's going to ask you things like this, okay? It may say, draw 3 arrays for the number 16. So I'm going to write down 16, and they're wanting me to draw 3 arrays. Okay, so the first step I want you to take is to think to yourself, then I need to come up with 3 sets of factors, okay, because they're wanting me to draw 3 arrays. Alright, so what times what equals 16, that's one set. Another what times what, and then another what times what, okay? Factor times factor. Alright, so now let's come up, since they wanted 3 of them, we went on and set it up the way we needed it to. So now let's think of 3 sets of factors that equal 16. First one I thought of was 4 times 4. Okay? Can y'all think of another one? 8 times 2. That's another one I thought of. And the last one will be 16 times 1. Okay? So that's 3 different factor sets that we can do when we're working this, okay? But that's not all it asked. It asked for you to draw 3 arrays using different factor pairs for each array. So that's exactly what we're going to do. So let's go ahead and draw an array for this 4 times 4, okay? So I'm going to kind of break it up so you can see it better. Okay, so let's work on the 4 by 4. And again, I'm going to use X's, and you can use dots or X's, whatever. Okay, so I'm going to do 4 X's. And they're wanting me to do it 4 times in 4 rows. So this is what that would look like. Okay? So I have 4 X's, 4 rows, and if I counted every single one of those X's, it would equal 16. So I'm done with that array. Okay, let's try 8 times 2, showing that array. This time I'm going to use dots, okay? So 8 times 2 would look like this. I would have 8 dots, 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to have 2 rows of that. 1, 2, 3, 4, 5, 6, 7, 8. So if I counted up all those dots, it would equal 16. So that's another way to do an array. And then 16 times 1. And so I would just start, I'm going to do dots again and do 16 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And because there's a 1 there, I only have to do 1 row. Okay? So for the number 16, I have 3 different arrays. Okay? And so that's how you're going to work those, and that is lesson 80.